Do you know how to do the integral of ln of tangent x from 0 to pi over 2? And this is a really interesting question because this integral, and let me write this tangent x as, this is the one of the method to solve this integral, but you can also let I is equal to that and then plug pi over 2 into, plug pi over 2 minus x into this angle, because inside the function of tangent x, because we have a formula that says the integral of f of x going from 0 to a, you can just put the a inside, a minus x inside the function. But here is another method. I'm going to use this as ln of psi x. We can write tangent x as psi x over cos x, right? So we can just use our rules, just use our, what's that called, the diffraction rule of ln. So you can change it to ln of psi x dx, and then minus the integral of ln of cos x. Both of them are going from 0 to pi over 2. So here is, these two integrals are really famous. And look at this integral and this integral, their answers are the same. Are really the same, because this integral is going from 0 to pi over 2. You can just put pi over 2 minus x inside. So psi of pi over 2 minus x is just cosine of pi over x, cosine x. So these two integrals, they are the same. So this integral and this integral, they cancel each other out. So over, you just get 0 like that. Of course, the answers of this integral is negative pi over 2 times ln 2. This really famous, really famous question. You need to check, you know. And also the ln of cosine x going from 0 to pi over 2, you're still going to get negative pi over 2 times ln 2 as well, because you can put pi over 2 into it. Just this integral is just equal to that. So, but do you wonder how to just keep the original integral, original function? But we are going to evaluate the integral of ln of tangent x going from 0 to pi over 4, like that. Going from 0 to pi over 4. This is really complicated, right? Because we can't just put pi over 2, pi over 4 into it. Just put pi over 4 minus x into it. We can change it to cotangent, right? So here's the deal. I would like to use substitution here. We would like to use u is equal to tangent x, and then take the, just take the inverse on one side. Inverse tangent, you can get inverse tangent of u is equal to x, like that. And then differentiate both sides, you get 1 over 1 plus u squared du is equal to dx. So over, put it back, just put the 0 into it, you get 0. Put pi over 4 into the tangent x, you get 1. So over, you just get ln of u divided by 1 plus u squared du. And here's the deal. Since u is a dummy variable, so you can name whatever variable you want. But I recommend not to choose e or I. Just avoid using e or I, because ln e just 1, right? And the ln I is pi over 2 times I. And just don't avoid using the variable like e and I. Just, I think other variable is okay. So, and L, be sure you need to write as this and not this, because it's really look like a 1, right? So the integral of this, we're going to use series here. I think this is my first video of using series. I think just, here's the deal. ln u, and then 1 over 1 plus u. I need to just change the variable first. I don't like u. I don't like to use u in the series, so let me just name it as ln x over 1 plus x squared dx. So here's the deal. I would like to use series on this 1 over 1 plus x squared. So the series of that is just the sum, the sigma, n is equal to 0, and then infinity. I forget how to pronounce this, sorry. So the series of this is -1 and then power of n, and then multiplied by our 2, just I forget, this is x power of 2k to n, because some people just choose this. This is also a dummy variable. I would like to use n here. So here's the deal. We can just flip it. Just first we put the constant inside the. We can put it. I think we can just flip it. So I think I can put it inside. First you put the lnx inside it, and then just flip this. Flip the notations, flip the sigma, and then flip the integral. So you can just put it as this: n is equal to 0, and then infinity, and then this -1 power of n, and then x time x power of 2n, like that. So for we can get this n is equal to 0, infinity. Since -1 power of n is a constant, so you can put it. I forget lnx, sorry. Since -1 power of n is a constant, you can put it outside the integral, like that. X power of 2 and lnx dx. So I would like to do this integral on here, since I don't have enough space for me to finish thing on. So 2n power of lnx time lnx. I would like to use integration by part. So we're gonna differentiate lnx and then integrate x power of 2n. Differentiate lnx, you get what? 1 over x, right? Let me move it to here. So integrate x power of 2n. First you add 1 to the power x power of 2n plus 1, and then divided by the new power. So this, sorry my fault. Just 1 over 2n plus 1 multiplied by that. You can just make a cross here. Just make a cross. It will be much beautiful. So first you do this time that, it become 1 over 2n plus 1 multiplied by x time power of 2n plus 1 time lnx going from 0 to 1. And then a constant, you can put it outside the integral, because the product you need to add the integral sign here going from 0 to 1. And then x power of 2n plus 1 divided by x, you pretty much just get x power of 2n dx. So here's the deal. When you put 1 inside it, 1 power of anything is just 1, never mind. And then ln1 is just 0. So first you get 0. And if you plus 0, ln 0, it should be 0 plus. When you put 0 plus inside, you get it goes to negative infinity. And 0 times negative infinity is an indeterminate form. But I'm not going to do the limit here right now, because whenever you do the integral like this, limit at x approaching to infinity, like that, and the x power of n lnx, make sure n should be greater than 0, like that. And then this is just equal to 0. You can just put it down. So over, just subtract 0, like that. And then here you just need to add 1 to the power and then divide by new power. And then this time the new power just minus 1 over 2n plus 1 and then square that. And then multiply by x power of 2n plus 1, going from 0 to 1. Like that. So we can just put 1 inside it. So 1 power of anything is just 1. So you pretty much just get -1 over 2n plus 1 square. And then you're gonna subtract negative of that. And then thanks to this 0, 0 of anything is just 0. And because we have assume that n need to be greater than 0. So n need to be greater than 0, so you can just put n is equal to -1/2 to get a 0 power. So over, just consider n is greater than 0. So 0 power of any positive number is just 0. So overall, this you're gonna subtract -0. So over you get 0. So the solution of this, let me just write down here. It's just equal to the sigma as x going from 0 and then -1 of n. And then because we have a negative here, let me just bring a negative sign outside. Right? And then we're gonna divide by 2n plus 1 square dx. And yes, it's really cool. Look at this. It actually have the form like that. Whenever you see the sigma, just the sum of -1 power of n over parentheses 2n plus 1 square, and then n start from 0 and then goes to infinity, and then this one is just equal to, in front we have a negative, and then this one is just equal to g, like that. And g, what's g though? And g is name is the Catalan's constant. You can check the definition on the internet, or you can put this g on Wolfram Alpha. And some people might use c, but I recommend not to use c because c is also means constant, right? So I recommend to use g more. So that's our solution of this integral. Just is equal to -g. It's about 0 point something this g. So that's our video.